Hello everyone. In this video I'll be covering the topic referring to the stability of carbocation intermediates. A carbocation intermediate is an organic molecule or an intermediate that has a carbon atom bearing a positive charge and 3 bonds instead of 4, since it underwent heterolytic fission by losing one of its electrons. Since the charged carbon atom does not satisfy the octet rule, it is unstable and thus is considered highly reactive once formed. This is represented in this diagram right here, in which a carbon atom forms 3 bonds instead of 4 because it's lost one of its electron via heterolytic fission to some other atom, forming a positively charged carbon. These carbocation intermediates are highly unstable and can be classified as primary, secondary, or tertiary carbocation intermediates, which I will discuss in this video. So to discuss the stability of carbocation intermediates, we need to understand the nature of the groups to which they are bonded and how they can affect its stability. We will be discussing carbocations bonded to alkyl groups. An alkyl group is considered as an electron donating group because they have low electron activities and thus do not hold on to, or attract the bonding pair of electrons as strongly, and thus they can be donated to a neighboring carbon atom bearing a positive charge to stabilize it. Thus, electron donating groups, the alkyl groups are electron donating groups that tend to donate their shared electron pairs towards the positive carbon atom to which that group is bonded. This helps stabilize the carbocation intermediate via positive inductive effect to spread the positive charge. So as you can see here, if it were bonded to 3 electron donating groups, then this carbon atom would be able to stabilize its charge by attracting its positive charge by attracting this electron pair, and this electron pair. These effects are called positive inductive effects, and such an intermediate would be called a tertiary carbocation intermediate, as I will discuss in this video. The attraction of the bonding pair of electrons toward the carbon atom holding or bearing the positive charge, this helps stabilize it, since this positive charge would decrease in nature and it would spread to the neighboring alkyl groups, thus forming a more stable carbocation intermediate. So to discuss the stability of carbocation intermediate, we should learn how to classify them as well. We have a primary, secondary, and tertiary carbocation intermediate, as I stated previously. A primary carbocation intermediate is an intermediate in which the carbon bearing the positive charge is bonded to one alkyl group only. As you can see here, this carbon atom is bonded to 2 hydrogen atoms as well as one alkyl group. Thus, this carbocation, or the carbon atom bearing the positive charge, can attract one bonding pair of electrons towards it to stabilize its positive charge and spread it over its neighboring alkyl group. And thus we state this primary carbocation is stabilized via one positive inductive effect. On the other hand, a secondary carbocation is a carbocation in which the carbon bearing the positive charge is bonded to 2 alkyl groups, as seen here, and 1 hydrogen atom. And thus this carbon atom can stabilize its positive charge via 2 positive inductive effects from 2 neighboring alkyl groups by attracting these bonding pair of electrons towards it and spread the positive charge over 2 neighboring alkyl groups, thus forming a more stable carbocation intermediate than a primary carbocation intermediate. A tertiary carbocation intermediate, on the other hand, is an intermediate in which the carbon bearing the positive charge is bonded to 3 alkyl groups, as seen here, 1, 2, and 3 alkyl groups, and thus can stabilize its positive charge via 3 positive inductive effects by attracting 3 bonding pairs of electrons from neighboring alkyl groups to stabilize its positive charge by spreading it over 3 alkyl groups. Thus, generally speaking, in terms of stability of carbocation intermediates, as you can see here in this series, as we go down this series through primary, secondary, and tertiary carbocation, the stability of the carbocation intermediate increases due to increasing number of positive inductive effects present to spread the positive charge. The least stable carbocation intermediate would be the primary carbocation intermediate, while the most stable would be the tertiary carbocation intermediate. Thus, these molecules in general, these intermediates, are unstable and require high activation energy to form. But to form the least stable primary carbocation intermediate would require the highest activation energy, and thus would be the slowest reaction, for example. While on the other hand, the tertiary carbocation intermediate, since it's stabilized by 3 positive inductive effects, would have the lowest activation energy required to form it. I'm going to read this note once again, since this is all clarified now. The alkyl group is an electron donating group that tends to donate the shared electron pair towards the positive carbon atom to which that group is bonded. This is called positive inductive effects, and thus the positive inductive effect helps to stabilize the carbocation intermediate by spreading the positive charge to neighboring alkyl groups. That probably covers everything I need to talk about regarding the carbocation intermediates and their stability. Thank you for watching.